So today we'll be continuing from integration. We have done exponential integration and trigonometric integration. Today we'll be doing integration involving ln functions. Okay, once we did differentiation, we were doing differentiation. And I asked you to differentiate ln x. So what was the derivative of ln x? That was 1 upon x, right?
Yes, sir.
So when we are integrating, we will say that the integral of 1 over x with respect to x will be ln x plus c. And again, if we try to integrate it the other way, for example, if I take x up, the power of x will be -1. If I increase 1 to the power of x will become 0 and it will divide by 0 and it will be undefined. So we do not integrate 1 over x in the way that we do the other algebraic functions. Okay. Again, if we were to integrate ln, which had a function as an input, how did we differentiate it?
The derivative of f upon a function x upon x.
The function was in the denominator, and the derivative of the function was in the numerator, right?
Yes, sir.
So again, we will have to make similar scenarios, or we'll have to use similar scenarios when integrating like function in the denominator and its derivative in the numerator. We'll simply say that this will integrate to ln of the function plus c. Is this clear?
Yes, sir.
Starting a few basic questions from the exercise, the very basic ones. And there are different ways to attempt the same questions. We'll be exploring those ways. How do we do 8 upon x? Or I can also write if there is a thing that there's a number that is just multiplying, the same thing can be written in this form as well, right or wrong?
Right, sir.
You can just do it 8 ln x even without taking 8 outside plus c. Is that clear?
Yes, sir.
Similarly, if we have 5 upon x, we just write it as 5 ln x plus c. Now what about 1 over 2x?
So we will take 1 upon 2 into multi.
Yes, so we will have half ln x plus c. Is that right?
Yes, sir.
Okay, this one's very easy. Okay, now about this. Now, how do we do this one? What function do we have in the denominator? A linear function. 2x minus 1. I just need the derivative of this 2 in the numerator, right or wrong?
Right, sir.
Observe now. Can I just bring the 7 outside? Right? Do I still have the derivative of the denominator in the numerator? I don't.
No.
Right? I can just multiply it by 2. And I can also multiply the denominator by 2. But instead of multiplying the denominator inside the integral, I write it as 7 upon 2. That simply multiplied the numerator and denominator both by 2. But the denominator multiple, I have not written it inside the integral, but outside. Is this the same thing? Simplified, you see, you can again get the same thing that was mentioned in the question. Is this right?
Yes, sir.
You have it in the particular form in which you have the function in the denominator and the derivative in the numerator. You write that ln 2x minus 1 plus c. Is this clear?
Yes, sir.
Now can you attempt the remaining two? If I just take the 4 outside, I'll have it as 1 over 2 minus 3x, right? Now I need a negative 3 over here, so I just multiplied the numerator with the negative 3 and the denominator with negative 3, but outside. So now instead of writing 4 upon negative 3, I'll just write it as 4 over 3. We do not like to associate a negative sign only with the denominator. That's right.
Yes, sir.
You can just take 1 over 2 outside and you have ln of 5x minus 1 plus c. You would have expanded it. Nothing to worry about. You would have got 5 over 10x minus 2. And you needed a 2 in the numerator, right? So you can put 10 in the numerator. So you multiply this by 2. You could multiply this by half. So you get half ln of 10x minus 2 plus c. Is that right?
Yes, sir.
Both will give you the same answer. Both are acceptable. Both are absolutely right. You will not, obviously, when you see it right now, you cannot say that both are the same, but trust me, both are the same answers. Both will eventually give you the same function. Okay. Moving on to question number 2. Attempt these ones. Okay. First one was easy. The integral of this will be 7x squared plus 2 plus x plus 2 ln x plus c. Is that right?
Yes, sir.
For the second one, you first decided to expand it. 1 plus 4 over x plus 4 upon x squared. Is that right?
Yes, sir.
Now we know that this can be integrated by writing it in this particular form. Now we integrate the integral of 1 is x. This will be 4 ln x. And this will be plus 4x to the power negative 1 divided by negative 1 plus c. So x plus 4 ln x minus 4 upon x plus c. We're done on this one. And similarly, this one, once you expand it, you get 25 minus 30 over x plus 9x to the power negative 2 dx. And once you integrate it, you get 25x minus 30 ln x minus 9 upon x and plus c. Is that right?
Yes, sir.
So far, so good. Let's do a few more. Attempt this one. This is how you should simplify once you have fractions as functions and you need to integrate them. Now just simply do the algebraic integration when you can on 5 over 2 minus, and remember 1 over x will integrate to ln x plus c. So 2 under root of x to the power 5 upon 5 minus ln x plus c. Again, this can also be left in index notation. We are not worried about that. And similarly, in the last one as well, we'll try to write them as separate fractions. 5x e to the power 4x upon 10x e to the power x minus 2 e to the power x upon 10x e to the power x. Once we simplify them, 5, 2 cancelled out, x and is cancelled out, and I'm left with e to the power. Remember, the powers will be subtracted here, 4x minus x upon 2 and minus 1 over 5x. This will become e to the power 3x. And once I integrate it, I'll get e to the power 3x upon 2 is already there. We multiply by 3 in the denominator, minus 1 over 5 ln x plus c. Is this clear? And obviously,
Yes, sir.
the power 3x upon 6 minus 1 over 5 ln x or ln x upon 5 plus c. So these were the very basic questions concerning the integral when you had to integrate in these particular forms. Using the derivatives to find the equation of the curve. We try to attempt those. Again, the pattern is the same. How do I get the equation of the curve once the derivative is provided? I'll have to integrate it to get the equation of the curve, right? So the integral of this will be 2x squared. This will be 5 ln x plus c. Just write it as x squared plus 5 ln x plus c. Plugging in the values, y is e square, x is e square plus 5 ln e plus c. E square cancelled out plus 5, then that just c is negative 5, I believe. So y is equals to x square plus 5 ln x minus 5. So that is how you can figure out the equation of curve once you are provided with the derivative. Let's try to attempt
Yes, sir.
on this one. Important thing to do in these kinds of questions is to use the exact values. Like they're giving you the coordinate, the x coordinate is e, and the y coordinate is 2 plus ln2. And I know I'll get the equation of y once I integrate this derivative, which is 1 over x plus e. Now, a common confusion is again e as a variable. Now, e is not a variable, it is just a constant. It is the Euler number. So that is just a constant. So the derivative already exists in the numerator, which is 1. So ln of x plus e plus c, right? So I just plug in the value in place of y, put 2 plus 2 ln2, ln of x plus e is 2. So what do we get? 2 plus ln2 is equals to ln2e plus c. Is that right? Now 2 plus ln2 using the product rule of log, I can write it as ln2 plus ln e plus c. Then puts are multiplying, the logs will add up. 2 plus ln2 and ln e is just 1 plus c. So the value of c will be 1. So the equation of the curve is y is equals to ln of x plus e plus 1. Is this clear? The question asks us to find the point q2 comma k also lies in the curve. It asks us to find the value of k. We cannot find the value of k until unless we have the equation of the curve. And how will we get the equation of the curve? Once we integrate this entire thing. So now I'll just integrate it 3x minus 2 ln x plus c. I'll just plug in the values of p, minus 2, 3, times 1 minus 2 ln 1 plus c. ln 1 is 0, 3 goes on that side, c is negative 5 I think. So y is 3x minus 2 ln x minus 5. Now I can just plug in the value 2 ln x minus 5. The value, the coordinate of y is k and the value of x is 2. K is 1 minus 2 ln 2. This is called the exact value of k. And we got answer like this as well. So this is the exact value of k. Is this clear?
Yes, sir.
Now let's go to part B. Tangents to the curve at point Q and R, where P and Q intersect at point R. So first we need to make equations of two tangents. What two things do we need to make the equation of a tangent? Gradient and one point, right? So M of tangent at P, the gradient of tangent at P, to is can be found using the derivative, which is 3 minus 2 is 1. Y minus y1 is equals to m bracket x minus x1. The equation is y is equals to x minus 1. This is the equation of tangent at P. Similarly, m of tangent at Q, 3 minus 2 upon 2. So 3 minus 1 is 2. Y minus y1, 1 minus. I'll just write it as ln4. 2 ln2 can also be written as ln4 is equals to gradient x minus x1, which is 2. So y minus 1 plus ln4, 2x minus 2. Y is equals to 2x minus 1 minus ln4. Don't worry about ln4, it's just a value. And you can just solve both of them simultaneously to get your values of y and then your values of x and then your value of y. This should be so x minus 1 is equals to 2x minus 1 minus ln4. X goes on that side, 1 and 1 cancel. X is ln4. Let this be the value of y, and the value of y is ln4 minus 1. So the coordinates of r are ln4 and ln4 minus 1. These are called the exact coordinates of r. Is this clear?
Yes, sir.